Without further ado, I'd like to introduce Ivan Ristich, who's going to be presenting the ultimate study of real-life SSL issues. Thank you.
Thank you very much. So I'll be talking to you today about SSL, and in particular about the various problems that we've seen in real-life deployments. Now, I've put the word ultimate in the title of the talk, not only because it's catchy, and it is, but because this study is actually the combination of about 2 years of our work. And so in about this 20 minutes time, I'll be giving you a brief overview of all the data that we've uncovered. And we basically set out to figure out exactly how SSL is deployed. And by now, we have done exactly that. So the first thing first, I'm going to tell you about SSL Labs, which is a sort of research effort that I work on at Qualys, and which started 2 years ago. So most importantly, if you go to the sslabs.com website right now, you will be able to download not only the most recent survey results and the data, but all the data from our previous surveys, as well as raw data. We also make raw data available to security researchers. So if you want to pursue other angles, you're more than welcome to do so. Also, there's a bunch of other interesting projects that you might be interested in. The most interesting project that we have, at least practically speaking, is the free SSL assessment tool. As it turns out, to assess SSL configuration is pretty difficult, so we spend a couple of months of our time developing a very comprehensive tool for analysis. So if you go to our website, you can actually type any domain name that you want, and the tool will go out, test any number of servers that it finds, and it will report the findings. So what you have on the screen right there, a couple of partial screenshots. So what we've tried to do, we made try to make this tool interesting to people who are not necessarily SSL experts. So for them, we have a grade, and then if you scroll down the page, you will find all the fine details about SSL and the configuration, and so on and so forth. So we had this tool running for some time now, well, actually for about a year, and then at some point we wanted to go further. So we decided to go and test every single SSL server that we could find on the internet. And this is essentially how surveys started. So in the 2 years, we did 3 surveys in total. The first survey that we did was in 2010, and we started with about 60% of all domain name registrations, which is about 120 million of those. And then we tried to find SSL servers behind each of those domain names. We found about 600,000 that participated eventually in our survey, and these are 600,000 sites with valid SSL certificates. Now, next year, we repeated the same assessment survey, but we were able to use more data. So what happened in the meantime, in between the 2 surveys, the SSL Observatory project was announced, and the EFF, they did something remarkable. They actually scanned the entire IPv4 space and discovered every single public SSL server that there is. And they made all this data available to everyone, and then we used it and got all the SSL servers, and they used our assessment technology on them. So by using their data, we were able to double the amount of servers to about 1.2 million. So basically, at the moment, between these 2 projects, the SSL Labs, you go to SSL Labs if you're interested in how SSL is used and configured, whereas the SSL Observatory is concerned with certificates. How are certificates used? And then those were the first 2 surveys. The third survey we undertook, we wanted to go deeper. We understood that these SSL configuration issues are not necessarily of immediate relevance, because as important as SSL configuration is, there is not really an immediate threat. However, we knew that there's basically an impedance mismatch problem with SSL. SSL is designed to protect any TCP protocol, which is great because then that protocol works with anything else. However, there's a problem that protocols that are being protected don't know anything about SSL. As a result, over the years, especially in HTTP, a number of issues occurred which are essentially impedance mismatch issues. And these issues actually cause SSLs to be completely subverted. And these are problems that are of immediate concern because they break SSL security today. So what we did for the deep survey, we took the Alex's top 1 million list of most popular websites, and we cross-referenced it with our own list of SSL certificates and came up with about 250,000 SSL sites. And these are sites, these are very popular sites that millions of people use. And every single one of them has a properly configured SSL server and a proper SSL certificate. And then what we did, we built a custom crawler that simulated browsers with the JavaScript execution and everything else. And we browsed to all the sites, watching for these various programming errors. So what I'm going to do, I have a bunch of slides. We're going to go through them very quickly. You can refer to them later, or you can go download the full data from our website. I have two parts. The first part is going to be about SSL configuration, and the second part is going to be about impedance mismatch issues. First of all, here's a high-level view of when we scan those 120 million domain names looking for SSL servers. Here's the pie chart that will give you the results, and I'll tell you the final result. We discovered that only 0.4% of all domain names actually had a properly configured SSL server with a proper certificate. So just a tiny, very tiny amount, which is not really surprising because if you look at the pie chart, a quarter of these domain names are not even operational. And then we have a bunch of other things running on port SSL3, and then the number is gradually reduced. And here is the sort of the high-level verdict. We give every site a grade from A to F, and you can see here that about 1/3 of all sites are well configured. And we reckon these are sites where people went and did their job properly, understood what they needed to do, and they did it. It basically takes from 15 minutes to half an hour to properly secure an SSL server, to properly configure it. The 2/3 of all sites, they generally have C's and D's. These are probably people who never paid attention to SSL configuration. What they did, they accepted the defaults provided by suppliers, by their vendors. The small number of Fs, these are probably people that tried to do something, but did it terribly wrong. So I'm going to look at I'm going to cherry pick from all the data that we have available. The next thing I want to look at is certificates. I have some good news here, which is that most websites have good certificates with good size, which is 1024 bits and 2048 bits. It's slightly disconcerting that if you look at the smaller pie chart in the lower left corner, you will see that certificate chains are in 10% of the cases misconfigured, which will probably result with problems when it comes to for end users, because they would occasionally get SSL warnings. Next up is protocol support. Terrible situation here. 15, 16 years after the discovery that SSL2 is weak and vulnerable, we still have about 1/2 of all sites, SSL sites, supporting it. In particular, we are not also seeing a very diverse use of protocols. The protocol that powers the security of the web today is TLS 1.0, but that's a pretty old protocol. There's very little adoption of modern protocols, which is a cause for concern short term. Next up is Cipher strength. Pretty good news here. You will see that virtually all sites support 128-bit encryption, which is sufficient. Some will support 256 bits. Unfortunately, it's also that a large number support weak cipher suites, which are completely unneeded, but the probably result of having everything enabled by default. And then finally, I have, this is the last slide on SSL configuration. This is the renegotiation slide. Renegotiation was a vulnerability discovered in late 2009. And by now, all the major vendors have patched their servers. And we were monitoring the rate of patching over time. So what you have is the results as I measured them in April. You can see on the large pie chart, we have the results of the 250,000 popular websites. You can see there that 35% of all these sites are actually still vulnerable to the renegotiation issue. there's a bit of a paradox here. If you look at the smaller pie chart, these are results of the global SSL configuration. Only 25% of the sites are still vulnerable, which shows us that more popular sites are actually less secure. So moving on to the more interesting part of the survey, this is a deep survey. As I was saying, these are issues that break SSL security today. And so when doing this survey, we started with the baseline. And the baseline is what we call the kind of state-of-the-art SSL security, which sounds really complicated, but it's actually very simple. All you need to do is you have to have a decently configured SSL server with the proper configuration, and you have to adopt 100% SSL on your website. And finally, you have to use something that's called strict transport security. Strict transport security is a special feature that tells browsers to never go, to always use SSL. No matter what link they're given, for your site, they will only come to you with SSL. And this is the critical piece, because most vulnerabilities, as you will soon see, actually come from the mixing of HTTP and HTTPS. So looking at it, this is the first test. We went to the homepage of each of these sites that we were testing and observed how many of them redirect plain text unencrypted links to SSL. Because if you keep your users unencrypted, they're just going to be vulnerable to Fireship or similar tools. I don't know, you probably heard of Fireship. That's the tool where you just run it in your browser, and then you just hijack all the sessions for popular websites such as Facebook and Google, whatnot. It's trivial. That's a great tool that shows something that we knew for a very long time, but it showed how easy it is to do. And what we see for this metric is that 80% of the sites are effectively vulnerable because they will accept plain text connections, and only 20% of the sites will redirect to be 100% SSL. Excuse me?
How many use STS?
Yeah, I'll tell you about it in a moment. So the next thing we said, okay, maybe not all sites are redirecting to SSL, but let's see how many are protecting credentials, because most developers will accept that they can use SSL to protect the user and the password. As it turns out, the results are here, well, surprising a bit, but and pretty depressing. In our software, we have built login form detection, and then we realized that more than 60% of login forms would deliver our plain text, which is very bad because if you have an active man in the middle, that guy can simply modify anything with that form. And even if the form is submitting over HTTPS, the man in the middle can modify that on the fly and submit to plain text and capture the credentials. The really surprising bit is that more than one-half of these forms were actually submitted over plain text as well. And you have to remember, these are sites that have well-configured SSL. The only flaw that they have, they're not using it. Next up, we have cookies. Looked at how cookies are used. We are interested in cookies because cookies are used for sessions. And if you have a session and a cookie that's not protected with a secure flag, that cookie can be teased out by someone who's with a phishing attack or with a man in the middle, simply by asking your browser to go to the plain text connection, and then your browser will willingly give out the cookie and allow the man in the middle to capture it. So going back to those 20% of the sites that actually redirect to SSL, if they don't have the secure flag set, they will be vulnerable, even though they have 100% SSL protection. This is a perfect example of the impedance mismatch problem. And you can see here there's actually a very small number of session cookies that are protected. It's only about 15%. HTTP only is a measure that's used to protect against session hijacking via cross-site scripting. That's slightly more popular, but if you look at the two together, it's only 1.8%, which is terribly, terribly small. I'll take questions a bit later. So the next question that we have here is mixed content. This is the problem where within the same page, you have, in a page you have a link. The page itself may be protected with SSL, and you can have one link that's plain text. The man in the middle can attach to that one unprotected connection. Maybe it's a JavaScript file, and that guy can hijack, piggyback on it, insert some malicious JavaScript inside, and hijack the entire page and hijack the complete user session. And here the situation is not good either. It's more than 20% of the home pages, because this is what we tested for, actually had this type of problem. So you can see how this sort of developed. We initially began our study wanting to find out how many sites are insecure. But after seeing many of these metrics, we realized that really virtually no one is secure. So what we decided to do then, we decided to look at how many sites are actually secure. And then we looked at our state-of-the-art protection, and then we started to look, okay, how many sites have redirection to SSL, how many sites use STS, how many sites have extended validation certificates, and I can actually tell you what the number is. We found only 9 sites among our some data sample of 250,000 sites that have all these 3 factors together. So these are nine sites in our study for which we could say that they are properly secure, have properly secure SSL. Now, don't forget, these are only popular sites because we didn't scan all sites in the world. The number is probably bigger, and there are smaller sites that are well protected. But on the other side, those are not necessarily sites that are used every day by millions of users, and these are. And there's a sort of a small disclaimer. There's one feature in strict transport security that forces SSL protection on all subdomains for a domain name, and none of the 9 sites actually use that feature. So even these 9 sites for which we can say they are secure, they're vulnerable to cookie injection, which you can do from a different subdomain, for example. And that's all I wanted to say today. Thank you very much. I will take questions now. Yes, sir. Thank you.
How many sites did you see that require client authentication?
The question is about how many sites did we see that require client authentication. The answer is we don't know. Because we cannot establish a SSL connection with such sites because we don't have a client-side certificate. We excluded them from the survey and we didn't look at them. But it's a very, very small number. I can tell you as much.
Can you go back to the authentication slide? Because it looked like you had both HTTP there, no HTTPS. Bullet 2 and bullet 3, it looks like they're the same thing.
Yes, no, the first thing is the first number is the forms, login forms are presented over HTTP. The second number, they're submitted over HTTP. So some of these that are presented over HTTP are submitted over SSL, which is sort of better, but still pretty bad. You were saying? No? Yes, sir.
What about redirection back to HTTP from HTTPS?
The question is about redirection from HTTPS to HTTP. I know it happens. It's difficult to measure it, and we didn't measure it because that would effectively require us to crawl the entire site to find all the possible use cases, and we didn't go there. It's terrible. The reason we narrowed down the number of sites for this deep inspection because it takes so much resources and requires a lot of data to store and process everything, so we try to sort of keep it within a reasonable amount of effort. Anyone else? Okay, thank you very much.